Why is there a maximum coefficient of performance for heat engines? Imagine trying to squeeze more work out of a machine than physics allows. It sounds impossible, but why is that? Today, we're going to find out why heat engines can only perform so well. A heat engine is a device that takes heat from a hot source, like a fire or a furnace, and turns part of that heat into useful work. It also releases some heat to a cold sink, like the air or a river. The goal is to convert as much heat as possible into work, but there are limits. The main reason for this limit comes from the second law of thermodynamics. This law says that in any real process, disorder or entropy must increase. It also states that you cannot convert all heat into work without some waste heat escaping. This waste heat must go to the cold sink, so perfect efficiency is impossible. The maximum efficiency a heat engine can reach is called the Carnot efficiency. It depends only on the temperatures of the hot and cold reservoirs. The formula is 1 minus the cold reservoir temperature divided by the hot reservoir temperature, both measured in absolute temperature units. This means that if the cold reservoir temperature gets closer to absolute zero, the maximum efficiency gets higher. But reaching absolute zero is impossible, so the efficiency can never be 100%. Now, when we talk about heat pumps and refrigerators, the same principles apply. The coefficient of performance, or COP, measures how well these devices transfer heat. The maximum COP for a heat pump depends on the same temperature difference. The closer the hot and cold temperatures are, the higher the maximum COP. For cooling devices, the maximum COP is the cold reservoir temperature divided by the difference between the hot and cold temperatures. However, as the temperature difference shrinks, the work needed to transfer heat increases. This means that even if the maximum COP is high, real devices will perform worse because of inefficiencies like friction, heat losses, and material limitations. These irreversibilities mean actual COPs are always below the theoretical maximum. In essence, the reason there is a maximum coefficient of performance for heat engines and refrigerators is because of the fundamental laws of physics. They set limits on how much heat can be converted into work or transferred without waste. The bigger the temperature gap, the lower the maximum efficiency, or COP. And real-world imperfections make it impossible to reach these limits. Understanding these limits helps engineers design better engines and cooling systems. They know that to improve performance, they need to optimize operating temperatures and reduce losses. This is why no heat engine can be perfectly efficient. The laws of thermodynamics keep that in check.